Chapter 1 Real Numbers Part 2. In Part 1 you have studied Euclid Division Lemma, Euclid Division Algorithm, and related to some problem also yesterday you solved. Clear? Uh, in Part 2 you are going to see some problems and proof. Clear? In exercise 1.1 second problem you see. So that any positive odd integer is of the form 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5, where q is some integer. You have to prove this. Clear? So for that you have to use Euclid Division Lemma in this proof also. See proof, let a be any positive integer you take. A be any positive. You can take x also. Clear? So here for our convenience I am taking here a. Let a be any positive integers. Then apply EDL to A and B. A and B. B I am taking here 6. Why I am taking 6 means in the proof you see we have to get 6q. Clear? 6%, this one remainder. This form we have to get. That's why you have to take B is what? 6. So we get, write that statement. These two have to use and to write. A equal to, that is dividend equal to divisor 6. We have taken portion plus remainder, where 0 less than or equal to or less than 6. So how the remainder is? Either you will get 0 or less than 6 you will get. You see the possible reminders are 0, 1, 2, 3, 4, 5. Up to 5 will come. Therefore, A can be you put that remainder, clear, remainder value 0. In this you put, what you will get? A can be, first what it is 0 means 6 cube. A can be 6 cube. Then 1, clear? A 1 remainder is 1 means 6 cube plus 1. 6 cube plus 1. Then 2, 6 cube plus 2. Okay, 6 cube plus 3. 6 cube plus 4. And 6 cube plus 5. So just replacing the value of R. Clear? A can be 6 cube plus 1, 6 cube plus 2, 6 cube plus 3, 6 cube plus 4 and 6 cube plus 5. Okay. Since A is odd, since the proof you see A is odd, A cannot be even. Clear? A cannot be even. A cannot be 6 cube, because 6 is the even number. Multiples of any, clear? You multiply any what number, you will get even only. Clear? So 6 cube. Then this even one, okay, 1 is the odd. You add means it will be odd number. Okay, then this also even number, because you are adding even, already even number. This you are adding even means again even you will get 6 cube plus 2. Then this is odd, this is even. 6 cube plus 4. Clear? So A cannot be 6 cube plus 2, 6 cube plus 4. Therefore, any positive odd integer, is of the form 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5. Hence 2. So any positive odd integer is of the form you will get, because A cannot be even, that is 6 cube plus 2, 6 cube plus 4. These all divisible by 2. That's why, okay, it cannot be even numbers. So any positive odd, remaining one is odd integers. That's why any positive odd integer is of the form 6 cube plus 1, 6 cube plus 3, 6 cube plus 5. So next problem we will see fourth problem, exercise 1.1, fourth problem. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Clear? So here what is square of any positive integer? Understand? So previous problem we have seen odd integers, okay, any odd positive integer, but here square of any positive integer you have to get the form 3m or 3m plus 1. Same way you have to do. First you have to apply Euclid division lemma. So let x be, you take x be any positive integer, any positive integer. Okay. Now then apply EDL to Euclid division lemma to this x, and b you take. B is here you see we have to get the form 3m or 3m plus 1. Here is what multiple of 3 this one. So b you take it as 3, that is divisor. Okay. Then we get this can be written as, so x is equal to 3q plus 1, 3q plus 1, where q is quotient. Clear? Remainder is r, you take remainder r. Clear? X is equal to 3q plus r, that is quotient remainder. Okay, b is we have taken 3. Clear? That's why x can be written as 3q plus r, where r is 0 less than or equal to r less than 3. Okay, so that means the remainder may be 3 or less than 3. That's all. Okay, that is the, therefore possible remainders are, therefore possible reminders are 0, 1, 2. That's all. Less than 3 you have to take up to. Less than 3 you have to take up to 2 you have to take 0. Clear? 1, 2. Now x can be, therefore x can be 0 you put, what will come? 3q. Then 1 you replace 3q plus 1. And 2 means 3q plus 2. So x is 3q, x is 3q plus 1, x is 3q plus 2. Now x equal to 3 you take. First take x is equal to 3q. What will happen? Now we have to what? Take square, because we have to find out the square of positive integer. Therefore squaring you do. So both the side is square means x square equal to 3q the whole square, right? Therefore this is x square is equal to, this is 9q square. 9q square. So now this 9 can be written as 3 into 3q square. 3 into 3q square. That is nothing but 3 into this you take fully what? M. Okay. Where m is 3q square for some integer m. For some integer m. For some integer m. Clear? Because 3 is integer. Okay. Cube is some quotient, that is also integer. Square means integer. So everything is integer. So that we have take it as what? M. Clear? Therefore that is equal to 3m. That is equal to 3m. Okay. Next what? Another number we have to do. Take another number. X is equal to 3q plus 1. Now squaring, same way squaring you do. Both the side you take squaring. What happening? Now a plus b whole square formula. A plus b whole square formula. So a square, that is 3q the whole square plus 2 into 3q into 1 plus 1 square. Here just applied a plus b whole square for a square plus 2ab plus b square. Okay, now simplify. So 9q squared plus 2 into 3 6q plus 1 plus 1. Now you see first two terms, you see what is common factor here? What is common factor here? 3q common, but we have to get the form 3m. Clear? So 3 alone you take common. Okay, you ignore q, only what 3 alone you take common. 3 you take common means here 3q squared plus here 2q. If you have doubt, you multiply and see. Once again you check 3 into 3 9q squared, 3 into 2 6q plus 1. Clear? Now you are getting the form, you see 3m plus 1. 3m plus 1 where m is 3q squared plus 2q. That's all. Okay, so you got the form 3m plus 1. Okay, next, and one more number there, and you take x is equal to 3q plus 2. So squaring, same way squaring. So apply a plus b whole square formula. A squared plus 2 into a into b plus b squared. Okay, just apply the formula. So here 9q squared plus 6q or 6q, here 6q into 2 there. So how much? 12q plus 4. Okay, but here you see first two terms only you have 3 is common. Clear? But here 1 we have to get, but here 4 is there, so 1 we have to get. That's why you have to split clearly into 2 terms. Okay, for our convenience we can, this 4 can be written as 3 plus 1. Clear? So 9q squared plus 12q plus 3 plus 1. This is stuff very important. You see this 4 you have to split into 3 plus 1. That is equal to, now you see these three terms, 3 is common. Okay, so take 3 alone common. 3q squared plus 4q plus 1. Again 1 plus 1 is there. Clear? Again plus 1 is already there. So here you see you just multiply 3 into 3 9 squared, 3 into 4 12, 3 into 1 3. Yes, correct. Therefore this can be written as 3m plus 1, where m is equal to 3q squared plus 4q plus 1. M is for some integer. Here written already. M is for some integer. Clear? You see all the 3 numbers, 3q plus 1, 3q plus 2. You take square means you are getting only this form only. 3m or 3m plus 1. Therefore square of any positive integer is of the form 3m or 3m plus 1. Hence proved. Clear? So this is very important questions. Okay, you practice 2 or 3 times. Clear? Today I will give homework also. The same problem you have to do without seeing. Clear? One time you have to do, because board exam definitely these questions they will ask. Okay, that's why practice more. You see next problem, 5th problem, exercise 1.1 5th problem. Okay, same way you have to do like 4th problem you have to do. So use Euclid Division Lemma to show that the cube of the square of we have seen. Okay, now cube of any positive is either of the form 9m or 9m plus 1 or 9m plus 8. Clear? Now let x be same way you take. Let x be any positive integer. X be any positive integer. Okay, then apply EDL to Euclid Division Lemma to x and b. X and b. B, clear? You have to take 9. B have to take 9. Is a 9 if you take means 9 numbers you will get. So it is very difficult. That's why 3 you take, because 3 is a factor of 9. That's why what you, if you take 3 means on simplifying you will get 9m, 9 plus m plus 1, 9m plus 8 you will get. Okay, that's why better you take 3 only. Right? Don't take 9 here. Okay, 9 if you take means 9 numbers, 9 number you have to take cube means it will be very lengthy. That's why for our convenience you take 3. Clear? We get x is equal to 3q plus r, where r is 0 less than or equal to r less than 3. Okay, therefore possible reminders are 0, 1, 2. Therefore x can be replace 0, 3q plus 1 and 3q plus 2. So now what you have to do, all the 3 numbers you have to take cube. Clear? Then you have to get the form 9m or 9m plus 1 or 9m plus 8 you have to get, right? So now first to take first number, x is equal to 3 cube. Taking cube on both sides, that means x cube equal to 3 cube the whole cube, right? So x cube is equal to 327, 3 times multiply, okay, q cube. But here we have to get the form what, 9 into this 27 can be written as 9 into 3, okay, then q cube. Understand? So now this alone you take as m, where m is some integer, that is 3 cube, okay, 3 q cube, some integer. Some integer, m is some integer, okay, some integer you take. So now first number taking cube we are getting 9m, okay, 3 cube plus 1, 3 cube plus 1, x is equal to 3 cube plus 1. Taking cube, x cube equal to 3 cube plus 1 whole cube, right? Now you see a plus b whole cube formula you have to apply. What is a plus b whole cube formula? A cube plus 3a square b plus 3a b square plus b cube, okay. So what is the beauty of this formula? A power you see decreasing, at the same time b powers are increasing, clear? So a cube plus 3a square b plus 3a b square plus b cube. You have to always remember this formula, okay. Now you just replace, here a is 3q I am taking, clear? B is 1, so replace it, okay. So put the bracket and replace, clear? That is, bracket is very important, okay. Put the a value in the bracket, that means 3q whole cube plus 3 into b square, that is 3q square into 1 plus 3 into 3q plus 1 square plus 1 cube, okay. Now this you simplify, what will happen? 27 q cube plus, here you see square is there, so 3 squared into q squared. So what is 3 squared? 9. 9 into 3, 27 q squared. So correctly how to simplify. So while simplifying, see first what, taking the square for both, clear? 3 squared is 9, then 9 into 3 27, then q squared you write, okay, plus 3 into 3 9 cube, 1 squared is 1 only, ignore it, plus 1 cube is 1, 1 cube is 1, that's all. So now you see first three terms, what is common? 9 common you take. 9 alone you take common. Of course q is also there common, clear? Don't take, because we have to get the form 9m plus 1, clear? That's why 9 alone you take common. So what will happen here? 3q plus 3q squared plus 9 taken common. So q alone will come, right? Q plus 1 separately there. First 3 terms only 9 taken common. Okay, plus 1, right? Separately. So now you take it as m. That is 9m plus 1. Where m is, you have to write, clear? Where m is, this fully you write. 3q plus 3q squared plus q. M is some integer. Clear? Now next you take next number, x is equal to, and x is equal to 3q plus 2. Again take cube on both sides. So therefore x cube equal to 3q plus 2 the whole cube. Same formula apply. A plus b whole cube formula. Clear? You know, see a cube plus 3a squared into b, okay, into b plus 3a, then b squared plus b cube is 2q. Clear? So just to write the formula, clear? The form. So now simplify. 3 cube is 27, q cube plus, here you see 3 squared. First you take what? 3 squared. 9 into 3 27, 27 into 2 54 q squared. Okay, so simplification part very important. Okay, you have to do very carefully. Okay, then plus 3 into 3 9, here is square 4, so 3 into 3 9, 9 into 4 36 q plus 8, understand? So first you square it, okay, then multiply. Square it means 4 into 3 12, 12 into 3 36. Okay, now first 3 terms you see here. First 3 terms, what is common? 9. Okay, 9 alone take common, that means you will get the form. Okay, so here you see what is remainder? 3q cube plus here 6q squared, because 9 6 are 54. Here 4q, 9 4s are 36 plus 8. If you have multiply, again multiply and see 9 into 3 27 q cube, 54 q squared, 36 q, right? So now you take this fully as m plus 8, where m is equal to 3q cube plus 6q squared plus 4q for some integer. Therefore, you see all the 3 numbers you get the form either 9m or 9m plus 1 or 9m plus 8. Clear? Therefore, cube of any positive integer plus iv means short form positive integer is of the form 9m or 9m plus 1 or 9m plus 8. Henceforth, that's all. So very important questions. Practice clear thoroughly. To do more number of times this problem, practice. Clear? Okay. So next we will see theorem 1.2, fundamental theorem of arithmetic. Fundamental theorem of arithmetic. So every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Here, so first you should know what is composite number. What is composite number? A number is having more than two factors. A number is having more than two factors, that is composite number. Starting from 4, 6, 8, these are composite number. Okay, that number can be expressed as a product of prime. What is prime? A number is having exactly two factors. A number is having exactly two factors. That is 1 and itself. Clear? 2 is prime, 5 is prime, 3 is prime, 7 is prime, 11 is prime. Already you studied in lower class. Okay. And this factorization is unique. Unique means only one. Okay. Only one. Suppose you are factorizing for 6 means 3 into 2. So everybody will will get 3 into 2 only. Okay. 6 means 3 into 2, the factors. Right. That is unique only. But the order may be changed. Okay. Somebody will write 2 into 3. Somebody will write 2 into 3. Okay. Somebody will write 3 into 2. The order may be changed. That only given. Apart from the order in which the prime factors occur. Clear? Understand? So this is called the fundamental theorem. Okay, we will see some problem. Example. Some number you take 135. Okay, 135 you have to what? Find out the product of primes. So only what you have to take prime number and divide. Okay. So 135 you divide with the prime number is 2 cannot possible. 3 also 5 you can divide. Here 5 divide means how many time will go? 2 time. What is the remainder? 3. Right? 3 means 35, 7 time. Again 3 also you can divide. Okay, that is 9. Again 3, 3. So this 135 can be written as 5 into 3 into 3 into 3. Right? That is nothing but, see all product of primes. This 35 is the composite number. Here, we expressed product of primes. Clear? That's all. So this can be written as 5 into 3 cube. Understand? This is, or this can be written as, okay, in order 3 cube into 5. Clear? That's all. Understand? So one more example also we will see. 175. Take divide and see. 175. Right? It will also go in 5 table. So 3 times 15, 25, 35. Okay. So here again 5 table. 7. That's all. Okay. Up to prime you have to divide. Clear? Now 175 can be written as 5 into 7. So 5 into 5 you know 5 squared into 7. 5 squared into 7. So very simple. Clear? Using fundamental theorem. Okay. We have done the problem. The simple method. Okay. Just what you have to find out the factors. That's all. Okay. Every composite numbers can be expressed in, okay, in the form of product of primes. That's all. Clear? So I will give 4 more problems. Clear? At the end of the video, you have to do it.